Alright, we are going to be solving the above question. It says two wooden planks 150 mm by 50 mm each are connected to form a T section. That is two rectangular section. Rectangular section 150 by what? By 50 mm. They are connected to form what? They are connected to form a T section, something like this, just like the way you are seeing it, like this. All right, so if a moment of 3.4 kilonewton meter is applied around the horizontal neutral axis, inducing tension, the neutral axis, inducing tension in the neutral axis, find stress at the extreme fiber of the cross section. That is, we want to find the stress at both the tensile stress and the comprehensive stress. Also calculate the total force on the cross section. All right, so for us to solve this question, the first thing we are going to do is to divide this thick section into two rectangles. All right, so that's it. So this one here is going to be the first, while this one here is going to be the second. All right, so the next thing we are going to do is to calculate the center of gravity from the what? From the bottom face about the neutral axis. All right, so the formula we are going to use is y bar, which is equals to a1 y1 plus a2 y2 divided by what? Divided by a1 plus what? A2. Because we are just having two rectangles, that's why we just have to. If there are three, we still continue by saying a3 y3 plus what? A3. All right, so the first thing we are going to do is to calculate the area of the first rectangle. We know the area of a rectangle is what? Length times breadth, right? So here we are going to have this to be what? This is going to be 50 multiplied by what? 150. So here we are going to have 50 multiplied by 150. So if you press this correctly, you are going to have 7,500 mm squared. All right, so that is what we are going to have. All right, so let's go for the second area of the rectangle. All right, so this is going to be 50 multiplied by 150. 50 multiplied by 150. All right, so in case you are just given the question only, you are going to be the one to draw the T section yourself. Take note of that. All right, so and you can see this is just the way it's going to be. All right, take note of that. So here we are still going to have 7,500 mm squared. All right, that is what we are going to have. All right, so let's go for our y1. All right, our y1 is the distance of the center of gravity from the bottom face about the neutral axis. All right, so and the first rectangle is this, so it's going to be, and the total distance is 150, so it's going to be 150 divided by 2, and 150 divided by 2 is 75 mm. All right, so for y2 now, y2 will be equals to one, you know, we have two of them, so it's going to be 150 plus the depth of the second rectangle is 50, so it's going to be 50 divided by 2, which is 25. 25 plus this, that is 175 mm. All right, so if you substitute now, we are going to have the distance of the center of gravity from the bottom face to be equals to a1, that is 75,000 multiplied by our y1. Our y1 is 75 plus our a2. What is our a2? 75,000 multiplied by our y2, which is 175, So divided by A1 plus A2. A1 plus A2, that is 75 plus 7,500. All right. So if you press this correctly, you are going to have your y bar to be equals to, if you press this and you sum them together, you are going to have it to be what? 1875, 1875, then 0, 0. All right. So okay, 30. So you divide this by, if you sum this together, you are going to have this to be 15,000. All right. So if you divide now, you divide this by this, you are going to have this to be what? 125 mm. All right. So it shows that our y bar is 125 mm. All right. So the next thing we are going to do is to calculate the moment of inertia of the what? Of the T section. All right. So moment of inertia of the T section about the neutral axis. So here we are having just two sections. So this is two rectangular sections, I1 plus I2. So I1 will be equals to BD cubed. That is the moment of inertia of a rectangle divided by 12 plus A1 into, so you are going to check between your y bar and your y1, which one is larger. So y bar, so we are going to have y bar minus y1 all squared. All right, so if you substitute now the base and the depth is 150, the base is 50 for the first rectangle. So it's going to be 50 multiplied by 150 to the power of 3 divided by 12 plus A1. Our A1 is 7,500 into our y bar. Our y bar is 125 minus what? Minus y1. Y1 is 75. Then everything all squared. So if you press this directly from your calculator, you are going to have this to be what? Our I1 to be nothing but 328, 12500. So this is going to be mm to the power of 4. So our I2 as well, our I2, the same thing, because it is also a rectangle, formula remains the same. BD cubed divided by 12 plus, this is going to be A2 into, so you will check between y bar and y2, which one is greater. So y2 is greater, so it's going to be y2 minus y bar all squared. All right, so if you substitute now, the depth is 50, the base is 150. So it's going to be 150 multiplied by 50 to the power of 3 divided by 12 multiplied by A2. What is our A2? 75,000 into our Y2. Our Y2 is what? 175 minus 125 all squared. So by the time you press this directly from your calculator, you are going to have your I2. Your I2 is going to be 2031, then 2,500 mm to the power of 4. All right. So now we can therefore calculate our I now, the moment of inertia itself now, which is I1 plus I2. So it's going to be 3281, 2,500 plus 2031, 2,500. So if you sum this together now, you are going to have your I to be nothing but what? It's going to be nothing but 531, 2,500. 5312500. All right, 25, this one is 1,000. All right, so this one is going to be mm to the power of 4. All right, so that is what our high is going to be. So you can also decide to take it to be in form of a meter. So this will be equals to, since our moment here is given in form of meter here, so let's take this to meter. So for us to do that, we are going to have this to be 5.1, 2, 3, 4. So that is 5312.5 times 10 to the power of minus 8. So 5312.5 times 10 to the power of minus 8 m to the power of 4. So that is what we are going to have. All right. So now the next thing now is to, so let's start with the first question now. So we are going to be going for our tensile stresses, but you are going to recall from Flegerer formula that m over I be equals to stress over what? Over y. All right. So now for our first calculation, which is tensile, so we are just going to put t here, and this one too, we're also going to have t. So let's make this to be the subject. It's going to be m multiplied by y subscript t divided by what? Divided by I. But our y subscript t is equals to our y bar. I hope you know the reason for this, because this is a simply because the question says two planks connected to form this, and inducing this, find the extreme. Okay, let me explain this. From the bottom, we said from the bottom to the neutral axis is our y bar, and the answer for that is I think I've cleaned that. Okay, our y bar is 125, and that side is subjected to what? Is subjected to tensile stress. The bottom part is subjected to tensile stress, while the top part is subjected to what? Comprehensive stress. All right. So that is why our yt will be equals to our what? Our y bar. So let's substitute now. So our moment here is 3.4 kilonewton meter. So this is going to be 3.4 times 10 to the power of 3. Then our yt is 125, but don't forget it is in mm. So we are going to divide by 1000 for us to take it to what? Meter. All right. So divided by what? I. And our I, we have already converted to meter. It's going to be 5312.5 times 10 to the power of minus 8. So by the time you press this value, you are going to have this to be equals to 8 multiplied by 10 to the power of 6, then Newton per what? Per meter squared, which you can further rewrite as 8 mega Newton per meter squared. All right. So that's what we are going to have. All right. So for our tensile stress, the formula will follow suit. Okay. But the only difference there is going to be our y subscript c. Our y subscript c will be equals to, because we already said that from the bottom to the neutral axis is our y subscript t, right? Which is also our y bar, right? So for us to get our y subscript from the top to the what? Neutral axis is going to be the total distance of the I section, the total depth, which is 200. So 200 minus 125. So 200 minus 125 is 75 mm. All right. So now we can therefore calculate our comprehensive stress. So the formula will remain the same as m multiplied by y subscript c divided by what? I. So if you substitute now, our m is 3.4 multiplied by 10 to the power of 3, then multiply by what? Then multiply by y subscript c. Y subscript c is 75, but this is in mm. We are going to multiply by 1000, divide by 1000, in order for us to take it to be in what? In meter. So this one divided by our I. our I is going to be 5312.5 times 10 to the power of minus 8. So by the time you press this correctly in your calculator, you are going to have this to be 4.8, 4.6 rather, okay, 4.8 times 10 to the power of 6 Newton per meter squared. So which you can further write as 4.8 mega Newton per what? Per meter squared. All right, so that's it. So we are done with the first question. So the other question says we should calculate the total force on the cross section. So we have thought the second question, though it is just 2-in-1 question, but it is 3 questions in this, guys. All right, so calculate the total force on the cross section. You have to take note of this. They said inducing tension, the neutral axis. Find the stresses at the extreme fiber of the cross section. We have done that, and also calculate the total force on the cross section. All right, so the first thing we are going to calculate before calculating the total tensile force on the cross section, the first thing we are going to do is to find the area in section. Area in tension, because they say inducing tension. So we are going to go for the area in tension. Okay, let me write it. All right, so the area in tension. Now, this is the area in tension from this point to the point of the neutral axis. So, and don't forget, we said from this point to this point is y bar, which is also what? Y subscript t. And then we have gotten it to be what? We have gotten it to be y subscript t. Y subscript t is 125, right? So it shows that this point to this point is the area in tension. So this point. All right. So it's going to be from this point to this point, which is 125 mm, right? So the area now is going to be length times breadth, that is 125 times 50. So the area in tension is going to be y subscript t multiplied by what? By 50. So which is equals to 125 multiplied by 50. All right, don't forget they are all in mm, right? We can take them to be in what? Meter. So this is going to be 125 times 10 to the power of minus 3 times 50 times 10 to the power of minus 3. So this will be equals to 125 times 50. That is 6,250. Then times 10 to the power of minus 6. So which we can write this as 6.250 times 10 to the power of 3, then times 10 to the power of minus 6. So this will be 6.250 times 10 to the power of minus 3, because 3 minus 6 is this. So this is going to be in m to the power of 2. All right. So that will be what we have for our area in tension. So now we can therefore calculate the total force on the cross section now. So we can therefore say the total tensile force now. Total tensile force now. All right. So the total tensile force is going to be the average tensile stress. Average tensile stress. So it's going to be average tensile stress multiplied by what? Multiplied by the area in tension. Area in tension. All right. So this will be equals to average tensile stress is what? 8 times 10 to the power of 6. Don't forget, and this one is in meter, right? Okay, so divided by 2, then multiply by the area in tension. So it's going to be 6.250 times 10 to the power of -3. All right, so if you do that now, you are going to have your answer to be what? 25,000. This is what? Newton, which you can further write as 25 kilonewton. All right. So this is how to go about this question. All right, I hope you are not confused. All right, so this is just how to solve the question. I hope you understand this. Thanks. Stay tuned for more interesting questions.